The skeleton has 5 main functions. So let's start with support. The skeleton provides a framework to keep you upright. The reason why you have a posture right now and you're probably sitting down is because you have a skeleton. If you didn't have a skeleton, your body will quite literally just collapse onto the ground and you wouldn't have any posture or structure to yourself. Secondly, we have protection. The skeleton is very important to protect your vital organs such as your heart and your lungs. So for example, your heart and your lungs are protected by your rib cage. 3, we have movement, and basically how this works is the muscle attaches to the bone through the tendon, and when the muscle contracts, it pulls on the bone to allow you to move. Next, we have blood cell production. Your bone, in your bone marrow actually, you have the production of white and red blood cells, which is really fascinating because your bone marrow is one of few areas in your body where brand new cells can be created. Next, we have mineral storage. Your bones produce calcium and phosphorus. Calcium is obviously very important for strengthening your bones, but it's also important to help you with your muscle contractions. Phosphorus, on the other hand, is also very important to help you strengthen your bones and keep it healthy. Bones are characterized based on their shape and their function. So firstly, we have long bones. Long bones are longer than they are wide, as you can see from the example here on the right, and they are used for leverage. So any movement where you have to lift something or move very fast, you're going to use your long bones. Very common examples of long bones are just like your thigh bone, your lower leg, your upper arm and your lower arm bones. These are obviously long bones because, as we can see, they are longer than they are wide. Next, we have short bones. Short bones are cubed or squared shaped, and they are very important for weight bearing activities, and they also provide support and stability. You can see a little sketch here on the right of what short bones would primarily look like. They're very sort of small and cube and awkwardly shaped. Flat bones have a broad surface area for muscle attachment, and they also help with protection of your vital organs. Very common examples of flat bones are areas like your sternum, your ribs, and even your skull. Next, we have irregular bones. Irregular bones also provide protection and muscle attachment. An example of an irregular bone are your vertebrae. Your vertebrae make up your vertebral column. Okay, now here's a diagram of all the bones you need to know for your exam. We're going to go from head to toe and we're going to classify each of them. So starting from your cranium obviously protects your brain and it's a flat bone. Now going down towards your shoulders, you have your clavicle, which is a long bone. You have your sternum in the middle of your chest, that's a flat bone. You have your rib cage made up of individual ribs, those are flat bones. Then going to your arm, and your upper arm you have your humerus, which is a long bone. In the lower arm you have both your radius and your ulnar, which are both also long bones. Now the way you differentiate between your radius and your ulnar is that the radius is the bone that's closer to your thumb, and the ulnar is the other bone. Now going forward, we have your vertebral column, which is made up of 5 regions. The first region at the top is the cervical spine. The second region is the thoracic spine. The third region is the lumbar spine. The fourth region is the sacrum. The fifth region is the coccyx or the coccyx, depending on how you want to pronounce it. Okay, now going down to your hands, we have your carpals around your wrist, we have your metacarpals, and then we have your phalanges. Going down towards your legs, we obviously have your pelvis right there around your hip area. Going further down, we have your femur, which is your upper thigh bone, and going down we have your tibia and your fibula in your lower leg. Now at your kneecap, at the front of your kneecap, you have a small bone called the patella. Now going even further down to your foot, we have your tarsals, metatarsals, and phalanges. Okay, now we've learnt about all these bones, but these bones have to meet somewhere, right? And they meet at a joint. A joint is just where 1 or 2 or more bones meet. And you need to know 4 different types of joints for your exam: the hinge joint, pivot joint, condyle joint, and the ball and socket joint. The hinge joint allows only 2 movements: flexion and extension. You can see from the door example here, this door has hinges right here by the wall, and these hinges allow it to only go in 2 directions: close and open. A hinge joint acts in a similar way. For example, at your elbow you can only move up, which is flexion, and you can move down, which is extension. Pivot joint allows only rotation. So here's a head right here looking like a balloon. Let's say you want it to look side to side. For example, you're in a rugby match and you're sort of scanning your environment. You're gonna have to look side to side. Let's say you're looking right, you're gonna have to slightly turn your head, and while you're turning your head, you're rotating around your neck, and that is rotation. Condyloid joints allow flexion, extension, and circumduction. If you don't know what circumduction is, we're going to talk about it very shortly. Next, we have the ball and socket joint. The ball and socket joint allows the most range of motion of any other joint. It allows flexion, extension, rotation, circumduction, adduction, and abduction. These are two examples of a ball and socket joint. Let's start with this one at the hip. So this is someone and both their legs right there. Let's say this is their pelvis right here in the middle, and their pelvis connects to this upper thigh bone here through a joint, their hip joint here, which is a ball and socket joint. So it's a similar thing at the shoulder here. Their upper arm bone connects to the bones that are up here through a joint right here called the shoulder joint, which is a ball and socket joint.